Hello students, hope you're doing good. So in this module, we are going to discuss about the solutions of 2023-24 questions across all CBSE sets given from the chapter relations. See, the very first question, a relation R on the set A is equal to set containing 1, 2, 3, 4, 5 is defined as R is equal to ordered by x comma y such that modulus of x square minus y square less than 8. So what kind of relation is given here? Modulus of x square minus y square less than 8. What is this modulus of x square minus y square less than 8? If you observe that, what kind of ordered pair satisfies the particular relation? What kind of ordered pairs means? I would say, right. So modulus of x square minus y square less than 8. First of all, whether this relation is reflexive, symmetric, and transitive. Coming to reflexivity. Okay, how to check whether it is a reflexive relation or not? You know about the reflexive relation. What is the definition of reflexive relation? If ordered pair x comma y belong to R for every x belong to the given set, then it is said to be reflexive relation. So here it is modulus of x square minus y square less than 8. In the place of x and y, you write only x. Then it is going to be modulus of x square minus x square less than 8. Modulus of x square minus x square means what? X square minus x square 0. Modulus of 0 is 0. So 0 less than 8. This is true or false? Absolutely true. Therefore, our relation is reflexive relation. Coming to symmetric relation. So, symmetry. In the case of symmetric relation, you already know that modulus of x square minus y square less than 8. It means x comma y belong to R. Then I am writing this as, if I take one minus common out, so minus of y square minus x square less than 8 still. Modulus of negative number is positive number only, right? So then you can write it as modulus of y square minus x square also less than 8. It means y comma x also belong to R. As x comma y belong to R, y comma x also belong to R. Therefore, R is symmetric, right? Now coming to transitivity. So what is that transitive relation? In the case of transitivity, x comma y belong to R. X comma y belong to R means modulus of x square minus y square less than 8. Suppose I would like to take two numbers where x is equal to, suppose 1 and y is equal to 3. No, y is equal to 2 if I take, then 1 comma 2, whether 1 comma 2 belong to R or not. See, 1 comma 2 means 1 square minus 2 square. 1 square minus 2 square is equal to how much? 1 minus 4 is equal to minus 3. Modulus of minus 3 is 3. 3 less than 8. So, x comma y, I am taking 1 comma 2 belong to R. Now, I am taking y comma z. What is y comma z? If I take 2 square minus 3 square, means I am taking y is equal to 2, z is equal to 3. Then, how much is this? Modulus of 2 square is equal to 4, minus 3 square is 9. 4 minus 9 is equal to minus 5. Obviously, modulus of minus 5 is 5 less than 8. So, what does that mean? Y comma z also belong to R. Now, see whether x comma z belong to R or not. So, what is x comma z now? X comma z is going to be x comma z. What is the value of x? Is 1 and z is equal to 3. So 1 comma 3, when you take them, modulus of 1 square minus 3 square is equal to modulus of 1 minus 9 is equal to minus 8. Modulus of minus 8 equal to 8 only, no? 8 less than 8. Is it true? It is not true. It means x comma z does not belong to R. Therefore, x comma y belong to R, y comma z belong to R, but x comma z does not belong to R. It means it is not transitive relation. So with this, we can understand it is reflexive and symmetric, but not transitive relation. So this problem was given in the set 65 of 1 of 1. Okay. Now coming to the second problem. What is the second problem given? A relation R defined on a set A is equal to X such that X belong to Z, and the elements are from 0 to 10. So X belong to Z is nothing but you can consider only integers. Therefore, what are the elements of A? Right from 0, right from 0, 0, 1, 2, 3, and so on up to 10. Means how many number of elements are there? Number of elements of A is equal to 11. And R is defined as R divided by X comma Y such that X is equal to Y is given to be an equivalence relation. Equivalence relation is nothing but it is reflexive, symmetric as well as transitive. Then the number of equivalence classes. Number of equivalence classes means, see, the relation is given X comma Y, right? Then how can you write R? R is equal to set containing 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, and so on, 10 comma 10, right? So this is of course an equivalence relation because it is purely reflexive relation. So as it is an equivalence relation, then what about the number of equivalence classes? What about the number of equivalence classes? Equivalence class of 1 is equal to 1, and equivalence class of 2 is equal to 2, and equivalence class of 3 equal to 3, and equivalence class of 10 is equal to 10. It means total number of equivalence classes from 0 to, from 0, right? Yeah, from 0 to, means here one more element is here, 0 comma 0 also. It means equivalence class of 0 is equal to 0. From 0 to 10, how many number of classes are there? Totally 11 number of classes. Therefore, the total number of equivalence classes is equal to 11, right? So that is about second problem. Coming to third problem. See what is third problem given here. A relation defined on set of human beings. You be very careful with this set of human beings because there are very important questions will be asked. Of course, this is one more question. 65 of 1 of 1. Okay, this question was given in this particular set. So where, how it is defined, X is 5 centimeters shorter than Y. Is dash relation means whether it is reflexive, symmetric, transitive or not. So coming to reflexive relation. In the case of reflexive relation, you can say X is means this is the first person and this is the second person. Now in the case of reflexive relation, you have to take only one person, right? So is there one person whose name is some X. X is 5 centimeters shorter than X. Is this possible? There is no person whose height is 5 centimeters shorter than him. That is why it is not reflexive relation. And coming to symmetric relation. In the case of symmetric relation, if X is 5 centimeters shorter than Y, then what about Y to X? Y is 5 centimeters longer than X, right? It is not shorter than. Therefore, it is not symmetric relation. And coming to transitive relation. Suppose if you take X is 5 centimeters shorter than Y, means X is equal to Y minus 5, and Y is, you can take one more person, he is Z, and Y is 5 centimeters shorter than Z. Then what about X and Z? X is 10 centimeters shorter than Z, not 5 centimeters, right? So therefore, it is not a transitive relation also. Therefore, it is neither reflexive nor symmetric and nor transitive relation, right? So coming to the fourth question. Now see this, these kind of questions will be asked most probably in any board examination, but you be very careful while answering these particular problems. Okay, so here the problem given is a relation R and the set n cross n natural number system, A minus C is equal to B minus C, show that R is an equivalence relation. When you are checking, when you are showing that it is an equivalence relation, first of all, reflexive relation. In the case of reflexive relation, A comma B is related to C comma D. This was given, and how this is defined as A minus C is equal to B minus D. Now, in the case of reflexive relation, you have to show that A comma B is related to A comma B. And before you apply this, you try to understand how this ordered pair is related to ordered pair. A minus C equal to B minus D. I'm just writing this as transpose D to the left hand side and C to the right hand side. Then it will become A plus D is equal to B plus C. This is for my understanding. so that I can say A plus D. A and D are extremities of the ordered pair, and B and C are means of the ordered pair. I can understand that. Okay. So now apply this AB related to AB. When you apply this, extremities are A and B, right? So it means A plus B is equal to B plus A. A plus B is equal to B plus A. This is right or wrong? Yes, absolutely correct. Therefore, our relation R is reflexive relation. Coming to the second relation, that is symmetric relation. In the case of symmetric relation, you know A comma B is related to C comma D. A comma B related to C comma D means what? A plus D is equal to B plus C. What are you supposed to prove now? You have to prove that C comma D is related to A comma B. For that, what I'm going to write, if A plus D is equal to B plus C, can I write B plus C is equal to A plus D? Yes, obviously. Then we can write B plus C as C plus D is equal to A plus D as D plus A. Right? Now, C plus B is equal to D plus A. C plus B is equal to D plus A means, can we say that C comma D is related to A comma B? Yes, obviously. Therefore, A comma B related to C comma D, then C comma D also related to A comma B. Therefore, it is a symmetric relation. And coming to transitive relation. So, in the case of transitive relation, you know A comma B is related to C comma D. A comma B related to C comma D means what? How it is defined? A plus B is equal to C plus B, right? Sorry, A plus D is equal to B plus C, right? A plus D is equal to B plus C. Right. A plus D is equal to B plus C. And now C comma D is related to another ordered pair E comma F. Then apply the same rule. What is the rule here? Sum of what is that? A plus D, right? Sum of extremes is equal to sum of means. Sum of extremes means what? C plus F is equal to D plus E. Now I'm going to add both the two equations. When I add them both, then what do I get? A plus D plus C plus F is equal to B plus C plus D plus E. Any cancellation here? See, one C and C gets cancelled, D and D gets cancelled. Finally, what do you get? A plus F is equal to B plus E. A plus F is equal to B plus E means what? A comma B is related to E comma F. Therefore, AB related to CD as well as CD related to EF. Therefore, AB related to EF. Therefore, it is transitive relation also. A relation is reflexive, symmetric, and transitive. Then what do you call the relation? Yes, it is an equivalence relation. Right. So, moving on to the next question. What is the next question? See, this is the fifth one. In this fifth question, you have which of the following statements is not true about equivalence classes AI where I is equal to 1 to n formed by an equivalence relation R on set A? Here, option A is given union I is equal to 1 to n AI is equal to A, and AI intersection AZ is not phi when I is not equal to Z. X belong to A and X belong to AZ, then A is equal to AZ, and all elements of AI are related to each other for every I. When you answer this problem, you have to consider one set A. You know what kind of set A? For example, I am taking set of all watches. Okay, set of all watches. So then I am taking the first set. This first set is set of all watches. I am taking set of all I watches. And A2 is I am taking set of all boat watches. Okay, I am taking different companies. And A3 is equal to some other company, set of all, some, this is Apple watches, this is boat watches, and something else, I would say Samsung watches. Okay, these three are three sets. A1, A2, A3. I'm just taking three sets because here it is AI, right? AI is nothing but I can be 1, 2, 3, 4, and so on. Any number of sets I'm taking. Now I'm going to identify this. As it is an equivalence relation, R is an equivalence relation. So A1 is equal to I watches, right? So it is I watches means Apple watches, B is boat watches, as well as C is Samsung watches. When I go to union, AI is equal to A or not. See, when I say A1 union A2 union A3, then I get all set of watches, right? Set of all I watches, set of all boat watches, set of all Samsung watches together called as set of watches, because these are all part of watches. Therefore, A is the correct option. Coming to B, AI intersection AJ. AI intersection AJ is nothing but, see, AI intersection, like if I find A1 intersection A2, what is A1 intersection A2? Set of all I watches and set of all boat watches. Do you get any watch in between belong to A1 and A2? No, you cannot. So A1 intersection A2 is equal to 5. But here what is given? AI intersection AJ is not equal to 5, where I is not equal to J. I is not equal to J, 1 is not equal to 2, but A1 intersection A2 we got it as 5. It was given it is not equal to 5. Therefore, B is not the correct option. So we got the correct option, right? So then we'll move on to the next problem. So coming to the next problem, see the sixth one. Sixth one is just similar to the previous one, fourth one we did. This is just similar to that. But anyway, this was given in board examination. I'm going to answer this problem. All right. So now coming to the relation, reflexive relation. In the case of reflexive relation, what is basically the relation given? A by B, A by C is equal to B by D, right? When it is A by C is equal to B by D, then we can say that A by C is equal to B by D. Can we do cross multiplication? We get AD is equal to BC. This is nothing but product of extremes, like A comma B is related to C comma D, right? So product of extremes is equal to product of means, just like for my understanding. Okay, now to check whether A comma B is related to A comma B or not, what is product of extremes A and B, right? So AB is equal to AB. It is reflexive or not? Yes, it is reflexive relation. And coming to symmetric relation. In the case of symmetric relation, AB is related to CD. AB is related to CD means what? You can say AD is equal to BC. May I write AD is equal to BC as BC is equal to AD. BC is equal to AD means CB is equal to DA. Yes, product of extremes and product of means, like C comma D is related to A comma B. Therefore, it is symmetric relation. Coming to transitive relation, in the case of transitive relation, A comma B is related to C comma D. A comma B related to C comma D means what? AD is equal to BC. Similarly, C comma D is related to E comma F. C comma D related to E comma F means what? Again, product of extremes, C and F, right? CF is equal to DE. Now, what I was supposed to do? Multiply both the two equations. When you multiply both the two equations, ADCF is equal to BCDE. BCDE, right? Any cancellation now? Again, C and C gets cancelled, as well as D and D gets cancelled. Finally, you get AF is equal to BE. AF is equal to BE means, what does that mean? AB is related to EF only, right? So therefore, AB related to CD, CD related to EF, therefore AB related to EF. Therefore, it is a transitive relation also. Therefore, it is symmetric, reflexive as well as transitive. Therefore, it is an equivalence relation. So coming to the seventh problem, once you see this, in this particular problem, we have a relation R on set A is equal to -4 to 4, B defined as R equal to X comma Y such that X plus Y is an integer divisible by 2. What is that integer divisible by 2? X plus Y is an even number. Let it be some 2m. Show that R is an equivalence relation. So first of all, reflexive relation. In the case of reflexive relation, you take only one element. X plus X is equal to 1, 2x. 2x is even number only, is divisible by 2. So therefore, it is a reflexive relation. And coming to symmetric relation. So in the case of symmetric relation, when X plus Y is equal to 2m, can we say y plus x also 2m? Yes, y plus x also 2m only, no? Therefore, it is symmetric relation. And coming to transitive relation, x plus y is a number divisible by 2. Let us say y plus z is also a number divisible by 2. Then we have to prove that x plus z is also a number divisible by 2. For that, what am I supposed to do? Adding all the equations, like both first and second equations. Then what do we get? X plus y plus y plus z. It means I get x plus 2y plus z is equal to 2m plus 2n. X plus z is equal to what? 2m plus 2n transpose 2y that side minus 2y. You can take 2 common out. M plus n minus y is equal to x plus z. What does that mean? X plus z equal to 2 into some number is nothing but even number divisible by 2, right? Therefore, x comma z also belong to our relation. Therefore, it is transitive relation. As it is reflexive, symmetric, transitive, therefore, it is an equivalence relation. And after that, also write the equivalence class of 2. Equivalence class of 2 means what? 2 is related to which are all the numbers. Okay. So 2 is related to which are all the numbers means what? 2 plus which number gives you an even number. See, 2 plus minus 4 is minus 2 is an even number. This is minus 4, and 2 minus 3 is not an even number. 2 minus 2 is an even number, as well as 0 is an even number. 2 is an even number. 2 4 is an even number. So this is what is equivalence class of 2, right? Coming to next problem, problem number 8. See, what is the assertion as well as what is reason? The relation R is equal to, I'm talking about assertion now, x plus y is a prime number. X plus y is a prime number and it is not reflexive relation, and where x comma y are from natural number system. So reflexive relation is nothing but what kind of relation it is? Set containing 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4 and so on. Now here x plus y is not a prime number. So x plus y is not a prime number. Suppose if I take 1 comma 1, okay, 1 comma 1, and I find 1 plus 1. 1 plus 1 is equal to 2 is a prime number or not? Yes, it is a prime number, but it was given it is not a prime number, right? X plus y is not a prime number, is not reflexive. X plus y is a prime number, is not reflexive. Sorry, I have written wrongly here. X plus y is a prime number, is not reflexive. So x plus y is prime number means 1 plus 1 is equal to 2 is a prime number. And what about next one? 2 comma 2. 2 comma 2 is nothing but 2 plus 2 is equal to 4, right? So 4 is even number, 4 is prime number or not? It's not a prime number. It's not prime. So here it is prime, here it is not prime. So E is not reflexive relation because one element is enough to say that it is not reflexive, right? So that it is not a prime, it is not reflexive relation, obviously, because if you see an element 1 comma 1 is a prime number. Coming to 2 comma 2 is not a prime number, right? Since it is not a prime number, therefore it is not reflexive relation. Therefore, assertion is correct. Coming to the reason, the number 2n is composite number for all natural numbers n. For all natural numbers n means what? Suppose if I take n is equal to 1. So 2 into 1 is equal to 2. It's a composite number or a prime number? It is a prime number, but not composite number. But what is given? The number 2n is composite number for all natural numbers. For all natural numbers. But it is not composite for n is equal to 1. Therefore, reason is wrong. Assertion is correct and the reason is wrong. Coming to ninth problem. See, this ninth problem is check whether the relation S in the set of real numbers are defined by S is equal to A comma B. So here A comma B is defined as A minus B plus root 2. This number is an irrational number. You will have to check whether this is reflexive, symmetric or transitive or not. Okay. Coming to the reflexive relation. In the case of reflexive relation, A and B should be taken as same numbers, right? So A is equal to A only. and b is also equal to a minus a plus root 2 is equal to minus a plus a cancel, which is equal to root 2 is purely an irrational number. Therefore, the relation is reflexive relation, right? So coming to the second relation, what is the second relation? Symmetric. What do you mean by symmetric relation? A comma b belong to R. A comma b belong to R means a minus b plus root 2 is an irrational number. Let me take two numbers a and b such that a minus b plus root 2 is an irrational number. I am taking a is equal to root 2 and b is equal to some 10, and then a minus b plus root 2 is equal to 1. Root 2 plus root 2 is equal to 2 root 2 minus 10 is purely an irrational number. But when I go to b comma a, what is b here? B is equal to 10, a is equal to root 2, and then plus root 2 is plus root 2. Minus root 2 plus root 2 cancel, which is equal to 10. It is not an irrational number, right? Does not belong to Q dash. What does that mean? B comma A does not belong to R, where A comma B belong to R. It means it is not symmetric. It is reflexive, but it is not symmetric. And coming to transitive relation. So in the case of transitive relation, let me take a comma b belong to R. It means a minus b plus root 2 is an irrational number. Is an irrational number means I would like to take a is equal to some 5 root 2 and b is equal to root 2 and c is anyway root 2 only. Okay. So 5 root 2 minus root 2 plus root 2 is equal to 5 root 2. This is purely an irrational number. And similarly, I would like to take b comma c belong to R. B comma c belong to R means what? B minus c plus root 2 is also an irrational number. It means b is anyway root 2, right? Now I would like to take c is equal to 6 root 2. And then root 2 is root 2 only. See, once you observe, root 2 plus root 2 is 2 root 2 minus 6 root 2 is minus 4 root 2 is purely an irrational number. But coming to a comma c. A comma c means what? You have taken a is equal to 5 root 2 and c is equal to 6 root 2. Then what is a minus c plus root 2? A is equal to 5 root 2 minus c is equal to 6 root 2 plus root 2. Once you observe, 5 root 2 plus root 2 is 6 root 2 minus 6 root 2 is equal to 0. Does not belong to Q dash. It means it is not transitive. Therefore, the relation is reflexive but neither symmetric nor transitive. Okay, this way you can answer the problem by giving suitable example. So when you are coming to the set of real numbers, you be very careful because there are a lot of chances to disprove the statement. So coming to the 10th problem. So what is this 10th problem? A relation R on a set A is equal to minus 10 to 10, x belong to Z is defined as R equal to x comma y. X minus y is divisible by 5, right? So when you coming to the reflexive relation, x minus y is nothing but x only because we are taking only one element in the case of reflexive relation. X minus x is equal to 0. Can you write this 0 as multiple of 5 or divisible by 5, right? So that it is going to be 0 by 5 is equal to 0. Therefore, it is reflexive relation. And coming to symmetric relation. So in the case of symmetric relation, x minus y is divisible by 5. Means x minus y is divisible by 5 is nothing but 5 into some other number. Then can we say that y minus x also divisible by 5 into some number only, no? But here, because you are taking minus of y minus x, x minus y is minus of y minus x. If some number 10 is divisible by 5, then minus 10 also divisible by 5, right? So it is symmetric. And coming to the transitive relation, in the case of transitive relation, let x minus y is equal to 5m and y minus z is equal to some 5k, and then subtract one from the other, sorry, add one to the other, then it will become x minus y plus y minus z is equal to 5 into m plus k. So minus y plus y cancel, x minus z is equal to m plus 5 into any number is divisible by 5, right? Therefore 5 into some r. Therefore it is transitive relation also. So therefore, it is reflexive, symmetric, and transitive. Therefore, it is an equivalence relation. And there is another part of this problem. What is that another part of the problem? Also write equivalence class of 5. Equivalence class of 5 is nothing but sum of 5 plus which number is divisible by 5. See, 5 minus 10 is equal to minus 5 divisible by 5. And after that, 5 after minus 10 you have minus 5. And after minus 5 you have 0. And then after 0 you have 5. And after 5 you have 10 also. This is what is equivalence class of 5. So this way we can understand